review on data mining algorithms. As we know that data mining is a process of retrieving knowledge from large amount of databases, that is data warehousing. Okay, so from the data warehousing, we are going to extract the needful information, that is called data mining. Okay, here I am going to discuss about various algorithms, and that too they have performed a survey on algorithms, and those are which are all the algorithms mostly used in the research field. So as a process, ACM, KDD and IEEE have made a research, that is made a survey on data mining algorithms, and they have asked some of the award winners to produce a list of algorithms on which most of the algorithms are referred in a journals. Okay, so on that they have asked for three things. One is algorithm name, justification about the algorithm, and representative application references. How many references have made? So all these three things they have asked to produce by the award winners, and they have produced with that. On the review over all those algorithms, they have produced top 10 algorithms. Sorry, top 18 algorithms they have identified. Under classification, they have identified C4.5, CORT, and then nearest neighbor algorithm, and then Navy base. These all comes under classification. After that, they have started statistical learning, means SVM, support vector machine, and EMS extensible, expectation maximization. And then association analysis, they have produced a priori and FP frequency pattern. Then under clustering, they have produced K-means and Bridge algorithm. Beginning and bagging and boosting, they have produced Adopt Boost is the top algorithm used in bagging. After the sequential pattern analysis, they go for GSP and prefix bag. The integration mining, they go for CBA. So these are all the algorithms they have selected as the top 18 algorithms. The upstairs finding redux, the graph mining, G-span. These are all the 18 algorithms they have put into a list, and on that they have selected top 10 algorithms which are all most cited in most of the research papers. Next. First one, second one SVM, third one a priori, fourth one K-means, fifth one EM, and Adopt Boost, KNN, and Navy base. All these three placed in the same category. All these were under 7th position, all were represented. So all these were in the 7th position, and 10th will be CORT. So all these were produced as the top 10 algorithms used in the research papers. On these, top 3 will be C4.5, which got the 52 votes, and SVM got the 50 votes, and then a priori got the 33 votes. So these 3 algorithms were considered as the top 3 algorithms. So on these 3, I am going to present on a priori algorithm, which is plays the most important role in association rule binding. Okay, because association is used for prediction purpose, we can go for association rules and all. So on that, under that category, I have chosen a priori algorithm as the most frequent algorithm. On the top 3, I have chosen a priori algorithm. Okay, so a priori means we are going to have a database set. On that, we are going to have a number of items. We go for introduction means if I am going to a shop and I am buying bread and milk. If I am buying milk means definitely I will buy bread. If I am buying bread means I can buy milk. Or if I am buying bread means I can go for buying the jam. Okay, so I am going to relate these 2 items. So if a customer is purchasing one item, is going for a next item. So the relationship. So if a customer buys bread means definitely he will buy a jam. So that decision I am going to make. For that purpose we are going for association rules. So for association rule we are in need of all these categories. First one, we need an item set that consists of items I1 to IN. We are considering the items as from I1 to IN, set of all the items. After that, transaction means whatever purchase, if you are purchasing means, so each purchase will be considered as a transaction. So for a transaction, how many items were used? So that comes into transaction. So transaction T, set of items. So on the set of items, how many items I am going to purchase in a single transaction? That is the T. And then transaction database means in the prior process, how many transactions are made and their items. So all those things put into a table called database. So for how many transactions were performed. So all those things put into transaction database. And next one, transaction. If you take a transaction means it will contain a set X, that is set of items I am going to purchase. If in a shop I am having 100 items, I am going to purchase either 4 or 5 items means. So among the 100 items and for a transaction I am going to purchase 5 items. So that is a set. So whatever items I am purchasing, that comes under X. So that X will present in I. So from the 100 items I am going to purchase 5 items. So X is the set of items I am going to purchase. So that 5 items present in the 100 items. Okay, so X belongs to, is a subset of I. Okay, so for a transaction T, if I am buying items I means a set X containing a set X. I am buying a X set of items, that will be a subset of I. That is a whole set. Okay, of some items, if X is a subset of T. So X must be, that is for a transaction I am buying a X set of items. The next one, association rule is implication of the form X is associated with Y. That is, if I am buying bread means I will buy a jam. If I am buying milk means I will buy a bread. So like that. Okay. So one item if I am purchasing, I will move for another item. What is the association between one item and another item? So so that is X is associated with Y, where X and Y will be a subset of Y. From the 100 items I am going to relate with one item with another item, another set of items. So that is association. So for association rule, you need a set of items is referred as an item set. From the I items I1 to IN, I am getting the set, that is item set. And then an item set that contains K items. If I am getting one item means it is one item set I can represent. If I am getting K items, 10 items means 10 item set. So for a set I am containing 10 items. So an item that contains K item means it is represented as K item set. Okay, the support of here when you are making decision on association, you have to consider two things. One is support and another one is confidence. So two things we have to be considered: support and confidence. That we will see later. Okay, so support of S. For representing support, we are using symbol S, and then we have to consider the confidence level also. Confidence and the support. Okay, so support of is a percentage of transaction database that contains X. That is number of transactions that containing the X item. Okay, so if I am buying a shirt, okay, 10 transactions I am taking. So on all the transactions I am having shirt. Okay, so if I am having 10 transactions, so what is the support? How many times the shirt presents? So that is the support of the transaction. So support of your item. Okay, so and the next one is, this is for single item. If I am taking shirt alone means I am going for 10 transactions. Among 10 transactions, how many transactions I am having shirt? That is one thing. Another one is X related, that is X is associated with Y. That is, if I am buying shirt and I am buying pant means both will be related. If I am buying shirt means X pant will be purchased. Okay, so association between these two. So in how many transactions both shirt and pant both will be presented? That will be taken. Okay, so either single item or association will be made on then how many items, how many transactions containing the association. That is X will be one item set, union Y will be another item set. So both will be presented in my database transaction. Okay, and confidence means if If I am taking association between X and Y in the transaction, number of transaction that contains these two relations, X associated with Y. After 10 transactions I am having means, how many transactions I am having X and Y. In how many transactions I am having both X and Y, that number of transactions by divided by how many transactions I am having X alone. That will be taken as a confidence level. Okay, how many 10 transactions means how many transactions I am having both X and Y, and divided by how many transactions I am having X. This will include both X and Y and X also. Okay, so individual I want to consider only X. So this will form the confidence percentage. Okay, so when we are going for association mining, you have to consider these two things. One is support and another one is confidence level. So this is example for a transaction having 5 transactions with that bread, jelly and then peanut butter, like that I am having 5 transactions. So I am going to find out what is the support and what is the confidence level, what is percentage of confidence. So support means number of transactions that is having the item. So if I am taking bread and peanut butter, both items, so how these two will be associated? What is the support for buying bread? Those who are buying bread will also buy the butter. So that peanut butter. Okay, so that for that I have to take the support and confidence level. So if I am taking this confidence level means how many transactions I am having both bread and peanut butter. So that to be considered. So here I am having bread and peanut butter 2 and then 3. So 3 that is 3 transactions I am having these 2 items, bread and peanut butter. Both items I am having in 3 transactions. So when we go for that, we will get a 60% number of transactions, and on that how many transactions I am having both the data items. That is called support. When we go for confidence means number of transactions containing both items X and Y, and number of transactions with only X. How many transactions with X? Okay, so if you go for bread and peanut, I already told you 3 transactions containing. With X means only bread we have to take. So first 1, 2, 3, 4. 4 items, 4 transactions I am having bread, and 3 on that 3 transactions I am having bread and peanut butter. Both will be present. So 3 divided by 4 I have to take. Okay, so I will be getting 75%. Okay, so like this we have to calculate support and confidence level. So based on that only we have to make the rules, association prediction. So for a problem, if a problem is given, we have to take all these things. Set of items, so far how many transactions have been taken, database, and then minimum support. If I am taking an item, if in a company means I want to, for yielding a profit, I want to sell at least 10 items per day, I have to sell 10 items, means I have to fix it as a minimum support. Okay, in among 100 transactions, at least I want to have 20 transactions with a particular item per day, means I have to set the minimum support level. Okay, so that is named as minimum support test, and then you can give your minimum confidence level also. Okay, and then you have to find out association rule. X is associated with Y with the minimum support and the minimum confidence. Okay, so if you are calculating support and the confidence level, we have to check whether the item is satisfying the minimum confidence and minimum support. These two to be considered. So when we go for problem decomposition, we have to find all the set of transactions with the support, minimum support, that are all satisfying the minimum support, and then frequent item set. How many times the item set was transaction that item set purchase was taken place. So that will be taken. So this is an example. So 4 transactions I am having, shoes, shirt and jacket, all these 4 transactions I am having. Among these, my minimum support must be 50%. 50% support will be present for all the items. If suppose shoes and jacket I am taking means only 2 transactions having that. So among 4, 2 transactions is having means, so 50% of support was resulted. Okay, so the item transaction will support the minimum support value. Okay, should satisfy the minimum support value. And when you are going for taking the frequency set means it should satisfy frequency item set property. That is, if you are taking a set of items that should be frequently existed. If it is not frequently existed means it will not satisfy even though if you add some other items with that. If one item is not frequently existing, even though if you add some other items with that, it will not exist frequently. Okay, so whatever items that you are taking, that must be in a frequent set, must exist in a frequent manner. That is not frequent items in a constant. So I am having these things, A, B, C, D were 4 items. I can combine these as A, C, D means this will be subset. And that will be taken as an individual subset. So this is an example calculating the association rules. Okay, so first I am taking 4 transactions with the items, number of items. That is, what are all the items purchased. So transaction ID and items that I am having. I have to get for individual items, I have to find out the support. For individual item, I have to find out the support. So for first item, if you take 1, 2, 3, 4, 5 items were there. Okay, existence is 1, 2, 3, 4, 5 items were there. So among that, for each item, I have to take the support level. So if I take 1 means, first transaction 1 is present, second transaction third transaction 1 is present. So number of support will be 2. If I am taking 2 means, second transaction, third transaction, fourth transaction. On all the 3, 2 was present. So number of support will be 3. So like that for each item, I have to take the support. Number of times, in number of transactions that item was present. So that is my support. So this from this I have to make my item set. So my minimum support is 50%. Number of transactions is 4. Among that 50% means you should satisfy at least 2 transactions. The item must present in at least 2 transactions. So if you consider these things, 2, 3 and this one will be rejected because it is not supporting the minimum support level. So at least 2 transactions my item should present. So we have to remove this one. So remaining 4 I have to take. Okay, so 1, 2, 3, 5 will be taken. So from this I have to form, this is for single items. Next I have to find X with Y. I have considered only X for individual items. I am finding the support level. Next I have to combine with X associated with Y. So if I am taking 1 and 2. So from these I have to consider 1, 2, 1, 3, 1, 5. After that 2, 3, 2, 5. After that 3, 5. So what are all the possibilities I have to take? Okay, so we have to combine with one item associated, we have to associate with another item. So from this same thing, we are going to calculate the support level. So if we are taking 1 and 2 will be there. If you see 1 and 2 will be present in only one transaction. Third transaction only they are having 1 and 2. So that support will be 1 and 3 means first transaction and third transaction. So 2 transactions. 1 and 5 means only in third transaction. So 1. So like that for all the transactions you have to take the support level. So from this we are going for same thing what you did here. It should satisfy the minimum support level 2 transactions. So among this you can reject the second and third. So first and third will be rejected. So remaining all the things satisfying minimum transaction support. So I can form this like this. So from this I have to combine with other items. 2 items that I have taken. First is with one item set X alone. Next is with X and Y. Next is with XY and Z. Okay, so xy associated with z. So 3 items we have to take. So when you go for 3 items, so here 1, 3, and then you have to take. When you are going for next item set, if I am having x comma y, x comma y, I want to add z means I have to take x comma y means in that I have to consider x which is present in the transaction and y and z must be greater than y. Okay, so for example, you see 1 comma 3, 1 is x, 3 is y. Okay, so among these, if I am taking the next item to be added, it must be greater than the y item. Z means z must be greater than the y. Then only I have to consider it with the next item. Okay, so 1 comma 3 means I have to consider this one. So which are all containing 1? There is no item containing 1. So if you go for two items containing, so 2, 3. If I go for again 2, 5. So these two I have to combine. So if you go for these two, this next item must be greater than the previous item. So if so, you can combine it with the as a third item. So you can take 2, 3 and 5. 2, 3, 5. So when you go for 2, 3 and 5, you have to check whether it is present in it is satisfying the minimum support. Okay, so 2, 3, 5 exist in third transaction, 2, 3, 5 exist in second transaction. So it is satisfying two transactions, it is satisfying. So minimum support 50% we are taking. So we can make the 2, 3 as our association. So if a person purchasing 2 means he will purchase 3 and 5. So this is algorithm for calculating all those things. So L1 will be a set of items and CK will be a whatever is shown in the previous. We have to predict the support for all. We are going to combine one item with another item association. For L1 frequent items, you are going from 1 to k plus 1 items. 1 to LK items. K item set means you have to go from 1 to k item sets. So when we are finding LK means, that is next item means you have to get it from the previous item. If I am finding the k set means it should be produced from the k minus 1 set plus one more item will produce my k item set. If I am going for k item set means it should be LK minus 1 plus one more item will produce my k items. So from the previous set only I am going to find the next set of items. So that is clear. See, k plus 1 equal to candidate generated from LK items. So from k items I am going to find the k plus 1 item. So for each transaction, increment the count of all candidates in C k plus 1 such that containing each transaction. Okay, so you have to increment one count to the previous count, you are going to increment that. So we are going to select only the items that support the minimum support level. That is 50% means at least 2 transactions will contain that 2 items. K items to be present in at least in 2 transactions. So this is also the same example. We have considered support level. Here we are going for confidence level. If I am having I1, I2, these are all the transactions. So how I am finding the confidence of a item, confidence level. First one is I1 and I2, and then 2 items means when I get I5 means what will be the confidence level. So I1, I2 and I5. If I am taking I5 to be added means I should take I1 and I2. So number of transactions. If I am having X associated with Y means I have to take number of transactions including X and Y and number of transactions including only X. So these two to be taken. X and Y total count divided by X, how many transactions X is happening. For using that only we are going to find the confidence level. So if you take this I1 and I2 as X and I5 as Y. So this is X and Y. So number of transactions containing X and Y and only X. So I1, I2, how many transactions present means? First transaction, fourth transaction, and then this one. four number of transactions containing I1, I2, number of transactions with X items. So 4. And then X and Y. So both how many transactions included? I1, I2 and I4. 3 transactions. So first one and then here I1, I2, I4. So 3 data plus. Okay, so number of transactions is 2. So 2 by 4 will produce your confidence level. Okay, so this to be considered. So this is for a priori algorithm, how it works. Advantages of a priori algorithm is when you want to find the items, you have to consider the whole data set, and for find whole data set to be considered and use large item set property from all those things, you are going to produce the association. And then easily parallelized, when you see the procedure, you can easily understand how one item is associated with another item. Right? So easily parallelized, easy to implement. These are all the advantages. When you go for disadvantages means it will consider all the transactions will be stored in a memory and that will be taken for the process. Okay, and it needs more number of scanning your database. If 100 items I am having means first individual X value I want to get the count means I have to scan from starting database to starting record to end record. Again I have to combine X with Y means again I have to take from first record to end record. So throughout all the for each and every how many steps I am going, for each step I have to consider from first record to last record. So scanning of the database will be larger in case of association. Sorry, a priori. That's all are a priori. When recent issues and all, they are going for hash tables using a priori algorithms for hash table and then partitioning. These two were dealing. They are storing their values in hash table, and for using the hash table, they are reducing the number of scans. So using the hash table, they can identify and they can refer the particular account. So that will be used. And partitioning means they will divide whole database into some partitions, and each partition will be handled separately, and all the results will be combined together, like a divide and conquer technique. That will be that is improvement in a priori algorithm.
Stop later.